Hey there, it's Dana from IDon'tGetItTutoring.com. Today we are going to be graphing linear equations. In other words, we're going to be graphing straight lines. So before we start, we need to understand what a linear equation is. And the ultimate equation of a line is this equation below. This is the standard. Every line follows this format and can be turned into this format. Y equals mx plus b. Now, we're familiar with y and x on our coordinate plane from the x and y axes, but we have m and b. Well, m is a slope. In other words, the slope is the average rate of change. How much it changes by each time. It can also be known as the rise over the run. For how many y goes up, this is how many x goes left or right. So basically, for however much y rises, this is how much x runs. This is also known as the change in y over the change in x. This little triangle symbol is technically a delta. You will see it frequently as a symbol to signify some sort of change, the change in a variable. Basically, this is y over x. Whatever our rise in y is, it's over our run in x. Now, b. B is our y-intercept. The y-intercept is the point that is on the y-axis. So b is the y value of that point. So it only gives us the y value. And it guarantees that when we see a number, or we don't for b, we know that that point always starts with an x of 0, and b is the y value. Okay, now that we're familiar with the equation of a line, let's get into our first example. Okay, let's start with an easy equation. Y equals 1/2 x. Simple enough, right? So, as you can tell, it follows the format y equals mx plus b. But wait, where's b? We have an m is a half, but where's b? Well, technically, whenever you add 0 to something, it stays itself. So if you really think about it, it's like there's an imaginary plus 0 here. It's there, but it's not really necessary to write it out because it's basically implied. Plus nothing. So really what we have here is a 1/2 x plus 0. Now, let's take a look at m. Our slope is 1/2, or 1/2. And like we said, our slope is y over x. So the change in y is 1, and the change of x is 2. So when y goes up by 1, x goes 2 to the right. And now for our slope, y-intercept. We have a y-intercept of 0. So technically we could put it into the point, right? We know that the x is always going to be 0 for our intercept. And now our y is 0. So we know for sure that the line goes through the point 0, 0. It definitely goes through the origin. Now, we can begin plotting our own points. Because we know that every time y goes up by 1, x goes to the right by 2. So our next point would be here. And once again, up 1, right 2, next point, up 1, right 2, next point. And then you could keep going until you reach the end of the graph. But what about this area right here? Well, just as you see, we have a positive over a positive, right? And if you go back to division properties of positive and negative numbers, we know that if you divide a positive over a positive, that's a positive. And if you have a negative over negative, that's also a positive. So, you could think of 1/2 as also -1 over -2. They equal the same thing. So, when you go up by 1, you go right by 2. And also, when you do that, you also can go down by 1 and left by 2. But you have to make sure to reverse both. So, when you go down 1, you go left 2. When you go down 1, you go left 2. And you can start plotting those points as well. And you could keep going until we finally have our line. Now, let me just get rid of this little stuff that's distracting from our points. I want to get a nice clean line with all our points. Here we go. And now for a line to connect them. Oops. What happened? There we go. Oh, having some technical difficulties. Apologies. Alright, so that's a good enough line. Don't forget to put little arrows at the end because this is a line. We are not graphing over an interval. We're not graphing over a certain amount of x values. This is technically implied that it's infinite. So it just keeps going on, and that's why it's very important to add those arrows on the edges. Also, it's important that you label your equation. So once you draw it, also just write the equation next to it, because when you're graphing multiple lines on the same plane, it can get a little messy and chaotic. Now, let's go on to another example. Okay, y equals x. Okay, so before only b was missing, but now m is missing too. What do we do? Do we put 0 for m too? No, actually, that is not the case. So, we know that there's an imaginary 0 right here. Right, so technically it's x plus 0. But what's before the x? Y equals blank times x plus 0. Well, we see that there's an x there, right? So if there was a 0 in front of the x and 0 times x, what is anything times 0? 0. So the line is not y equals 0. No. So m can't be 0. That's not possible. Okay, so if it's not 0, what other number can it be? Well, what number can you multiply by anything and you still get that original number that you multiplied by? So let's say you did x times some number. How can you still get x? Or 3 times what number gives you 3? That's 1. So 1 times anything, anything times 1 remains itself. So in that sense, we have y equals 1x plus 0. So 1 is our slope, and 1 is equal to 1 over 1, right? So when y goes up by 1, x goes up by 1. And also when y goes down by 1, x goes down by 1 as well. Or should I say left by 1. Okay, so now we know how much to go up and down with x and y. And let's do the same thing for our y-intercept. That's going to be 0, 0. So once again, our line is going through the origin, and we know that every time we go up 1, we have to go right 1 as well. And then it's easy to keep plotting. Just keep going up 1, right 1. And now, on the other side, down 1, left 1. And there you go. Just keep plotting the points until you reach the end of the graph. And now all you have to do is make a line to connect them. Don't forget your arrows at the ends. There you go. That is a line y equals x. Now, let's say we wanted to add some numbers into this. Let's use a different color so we can make sure we know the difference between the two lines. Let's say we wanted to do y equals 3x minus 3. Finally, some numbers, am I right? We're not just guessing at this point. We're not trying to discover or solve what numbers could m and b possibly be. They're given to us right here. M, our slope, is 3. And b, our y-intercept, is -3. You always have to include the sign in front of b. Over here, since it's addition, it's implied that a positive number, you don't write a plus in front of every positive number. But in negatives, it's important you don't forget the negative sign. Okay, so we know our slope is 3, and 3 as a fraction is equal to 3 over 1. So when y goes up by 3, x goes right by 1. And vice versa, you can go down by 3 and left 1. Okay, and now for our y-intercept, right? Let's put it into the point. So x is always 0, and then our y is -3. So now for this line, we have the point 0, -3. So we know that this line, y equals 3x minus 3, has to go through this blue point right here. Now let's apply what we did right here. So as you go up 3, you go right 1. And you just keep going. Keep plotting them once again till you reach the end. And then you could start going backwards. 3 down, 1 to the left. Down 3, 1 to the left. And then there you go. So again, I'm going to clean this up a little so we have some nice clean lines. Oops. Okay. Now, let's connect our new line. This is y equals 3x minus 3. And there we go. Do you see why it's important now to remember to label your lines? Because let's say I drew like 4 other lines here. And I don't think you have like 7 different colored pens on you to be able to tell which one is which. So you see things could get a little messy. So it's always good to label them just so you know which line is which, because they all look pretty similar in one way or another. They're all lines with arrows at the ends. So yeah, that's how you graph lines with a positive slope. But now let's try a negative slope. So with a negative slope, you guessed it, m is negative. Okay, so let's try a line with a negative slope now. Let's do y equals negative 3x plus 2. I'll be nice. I'll give us a positive y-intercept this time. So, like I said, when you have a positive over a positive, that's a positive. And then a negative over a negative, that's also positive. It's true that if you have a negative over a positive, that's negative. And if you have a positive over a negative, that's also negative. So when you have pairs, it's positive. Positive pairs. And then when you have not matching, that's negative. Negative, no match, positive pairs. Okay, that's one way to remember it. So now for our negative slope, they can't match. We need to have something positive on the top and something negative on the bottom. Now, we know for sure that negative 3 could be done as negative 3 over 1, right? Because any number over 1 is itself. So, you see, we already have the negative on top and then the positive on the bottom. So, negative 3 over positive 1 is also equal to positive 3 over negative 1. So, you could do negative 3 over 1 or 3 over negative 1. And then from there, as y decreases by 3, x increases by 1. So you go down 3, but right 1. And that means for here, you go up 3, but then left 1. And for y-intercept, that's easy. That would be the point 0, 2. So 0, 2. Oh, no. Okay, 0, 2. And then from there, let's apply this first, and then we'll get to the second part. So down 3, and then right 1. Down 3, right 1. And you keep going. Oh, I did it. Oops. Down 3, right 1. Okay, and then let's go up 3 and left 1 now for our other side. Up 3, left 1. Up 3, left 1. And we don't have any more room. So now, once again, let's make a little line to connect them. Can't forget our little arrows at the end. Let's label our line. There we go. Now, can you tell the difference between the lines with a positive slope and a negative slope? As you can see, they're going two different directions. This is something important to know. When the slope is positive, the line looks like this. When you go from left to right, it's going up from left to right. When you have a negative slope, it's always going to look like this, in the opposite direction. So it's going down from left to right. So as you can see, positive slopes are going up as you keep going right, and negative slopes keep going down as you go right. Something to keep in mind, just in case. And yeah, that concludes our lesson for graphing linear equations. Thank you so much for watching, and good luck. Bye.